All right, we're going to try making a small little project that will take MIDI files and turn them into, animate them and turn them into video. In order to do this, the first thing we have to do is actually build a program that can parse MIDI. I've exported this MIDI file from a small project I was working on a couple months ago, and we're going to try and build a parser to parse it. Anyway, well, that actually correct. Anyway, to start this off, we're going to have to explain how a MIDI file works or how it is formatted. The first thing we have to understand is that a MIDI file is a stream of chunks. Each chunk follows a very specific format in which there is there are 4 bytes that define the chunk type, followed by a 4-byte unsigned 32-bit integer, followed by data of that unsigned 32-bit integer length. So it is a length prefix byte array, and we're going to take a look at this MIDI file here. As you can see, the first chunk is going to be MTHD for the string, and that's going to tell us that this first chunk is the header. Now we're going to move into the length prefix, and this is a 6-byte header, and this is typical of most MIDI files. It's going to be only 6 bytes long. And sorry, I'm just kind of losing track here. So it's going to be a 6-byte data section, which means that these 6 bytes here are the entire data section. The first 2 bytes are going to tell us the format of the file, which is going to be format 1. We'll learn what those are shortly. Second 2 bytes are going to be the number of tracks in the file, and the third 2 bytes are the time division, which gets a little bit complex, and we'll learn about that later. And then this is followed by another chunk. This one is a track chunk, and there'll be 50 of these in this file, as it said there were 50 tracks. Each one's going to start off with MTRK. This one is in particular I think 56 bytes long. And then the track chunks are actually streams of events. Each event is prefixed by the delta time from the previous event. But here's the trick. In MIDI, the delta time is always given as a number of ticks. And these ticks are calculated through awareness of what the current time division is, along with the tempo. So, for example, right now, each MIDI tick is about, I want to say 1 millisecond long, somewhere around there. We get this because there are 500,000 microseconds per quarter note, and our time division is 480. 500,000 divided by 480 gives us the number of microseconds per tick. So anyway, let's go ahead and start into coding the actual parser. To do this, we're going to need a file, and I've already got a file here for it. Was it? I can't even see it there. All right, and what we're going to have to do first is we're going to have to read the file's contents. So then let's do this using iutil, read file, file name. And I'm just doing this all in Golang, or Go. Nice, easy programming language. And I mean, if I were to go ahead and print this out and just print out the length of the file here, and you can see that Visual Studio Code automatically fills in the inputs for me, which helps out a ton. So then let's see here. I'm just going to run this code really quick just to prove that we're reading the file. 54.8 kilobytes. If you're doing it using the SI prefix. If you're doing it using the binary prefix, it'll be a little bit different. I don't know how to calculate that except for the fact it's a power of 2. I mean, I can't do that off the top of my head. But, all right, at this point, we're now going to want to start into parsing the file. And I'm going to create a new folder here called Parser. We're going to put all of the parsing functions in here. We're going to create a file for we're going to create a source file that'll manage the MIDI file type. And we're going to create a function, parse MIDI data, and it'll take the data as a byte array and return a MIDI file or an error. And I'm just going to take a quick step back here and just going to update this so that we have some error handling. And we also get the function working in here. So we're going to do parsed error parser.parse MIDI data contents. Did I call it parse MIDI data? Yeah, I did. And then let's see here. I'm just trying to figure out the best way to do this. We'll ignore that for right now. I'm going to be using a package called the errors package. And it'll give us much more. It'll give us full stack traces and such with errors. It allows us to trace it throughout the program. And we're also going to, let's see here. Let's return right there so we just get out of the program there. Let's also log here. Let's do an interface on this one. That should simplify it some. All right. So now onto the actual file parser. First thing we're going to want to do is we're going to create a function that will chunk the file. I'm just going to create this in a new source file. So I like to keep a lot of this separate just for structure. And let's see, we're going to have a chunk type, which is going to be a string, and the data, which is going to be a byte array. And since this doesn't have to be exported, we'll just do it as next chunk with lowercase. And let me see here, we're going to be doing, we're going to need to have a reader. So we're going to take the reader, we're going to use a bytes reader for all of this. Yeah, we'll keep the chunk exported. So now we'll get our bytes reader imported. And now we actually have to be able to read a chunk. So we need a buffer to throw our data into because we're going to read the first 4 characters. And this is going to be a buffer of length 4. And we're going to read into the buffer. So then here equals our read buff. If the error is not nil, then we're going to turn nil, but we're also going to do something neat here. We're going to wrap the error and say could not read chunk header. Or I should actually say chunk type now that I think about it. All right, so then now that we've read now that we have that, we're going to save it as chunk type, and we're going to convert it to a string. Luckily, this is easy to do in Go. It's just string as a function. Yeah, we're going to take the buffer there. Now we're going to go and reuse that same buffer. And this time we are reading the length. So that was a uint32, and we're reading that off of the buffer. And we're reading that from the reader. And once again, if error does not equal nil, return nil. Errors wrap. Error could not read chunk length. Yay for Go format, doing all that for me. Now what we're going to do is we're going to, all right, so we've got that. Now we need to convert it into a number. Luckily, this is easy to do. This is actually really easy to do. Binary, big endian, uint32, buff. There we go. Now we have length as a number there. Now we're going to reassign buff. And is this the best way to do it? Yeah, this is probably one of the better ways to do it. So we're going to reassign buff, and we're going to make this now a byte array of length. Although I do have to change it to a regular integer, otherwise Go will complain about type issues. And now we can actually read the rest of the chunk. All right, now that we have all of this, we can finally construct the chunk and return it. Let's do type first. And then the data. And there's our function to read a chunk. So now if we go into here, let's go ahead and first create our reader. So bytes new reader using that. And we're going to be reading a few things off of this first chunk. So format, track count, and the time division are all uint16 values, and we're going to read all of that right off the bat. So first, we have that loaded. We're going to load the first chunk. So this is going to be the header chunk. And this is going to be read as a next chunk R. And if there's an error here, we're going to wrap it as well. That way it just makes it really easy to trace. I mean, by wrapping the errors here, it makes it really easy to trace what went wrong and where it went wrong. And wow, it's snowing outside. That's a little bit surprising given that it's March. Well, again, late March, we usually get snow around here. All right, so now we have the header chunk read. Now we actually have to process it. First thing I'm going to do is I'm going to make sure that it is at least 6 bytes long. The MIDI spec actually says that it has to be at least 6 bytes long, and we can ignore anything after 6 bytes because that would be kind of sequencer specific or things like that. So if the length of the header chunk data is less than 6 bytes, turn nil, there's dot rf, invalid header chunk length, expected. And we're going to go ahead and put in the length of the header chunk. That way we get a nice error message out of it. Now, I like having nice error messages. They make things a lot easier to trace whenever things go wrong. So I always want the error messages to be unique. That's another little thing. I'm also just going to really quick create a MIDI file to return here. And that way we get rid of a little annoying error that keeps on annoying me on the screen. All right, now that we have that, we're going to go ahead and we're going to read the format information from it. And this is actually even easier to do because we don't have to load it into any buffered readers or anything like that. We don't have to use the IO reader interface. All we have to do is just select the 3 UN to 16 values right from the byte array. So we're going to do, let's see here. Format is going to be binary, big endian, UN16, and it's going to be HDR chunk data 0 through 2, so it grabs the first 2 bytes. Now we're going to do this with the others, so track count, big endian. Actually, let's pull the track count out really quick. And we'll do it here because you'll see why in a moment. Actually, do I have to? Well, I'll actually construct this as a value here. So we'll do like that. And we'll just return the file there. Endian UN16, HDR chunk, data 2 through 4. Our time division, binary big endian, 16 HDR chunk, data 4 through 6. And that actually goes through and gets the basic data from the file. So if I were to run this now, there we go. Format 1, track count 50, time division 480. And if you look back at our source file, format 1, the track count 50, and the time division 480. All right, so that finishes up the first to-do here, which was to actually parse the MIDI file itself. And we can also knock chunk off. Now what we're going to do is we're going to do the track parsing. To do this, we're going to create a for loop. And since we already know how many tracks should be in the file, we can greatly simplify it. So let's go back to the file. And we're going to say, let's create something else here. We're going to create track.go. Track struct. And we're going to use a little bit of polymorphism in this. I know Go isn't an object-oriented language, but MIDI is a pain in the rear end, so I'm willing to make a sacrifice for that. All right, so moving on to the next step. Wow, that stung a little bit. All right, moving on to the next step here. We're going to parse the tracks. To do this, let's see. I need a tracks here. It's going to be an array of track, which we just created. And tracks make track. And this is going to be the track count. Actually, I'm going to pull this out. So then file dot tracks equals make track file dot track count. That puts in the tracks there. And now we're going to go through, we're going to loop through each track. I is less than file.track count I plus plus. So we already know the number of tracks that we can just loop through like this. And for this, what we'll do is we'll do each chunk through next chunk. And this is actually going to parse each of the track chunks out. First off, if we get an error, then we're going to return nil and errors.wrap saying error could not read track chunk. And if the chunk type is not mtrack, then we're going to create an error here. Actually, let's give extra data in this. This is going to be the chunk type. Oops, did I accidentally comment that out? I did. What is this error on? Oh, because this is actually a uint 16. There we go. All right, so now this will actually allow us to read out each track chunk. Now what we're going to want to do is we're going to want to have each track parsed. So we're going to say, let's see, and actually to make use of things a little bit nicer, let's do this here. Tracks, track, file tracks, and then we'll just say track parse, and this doesn't even have to be exported, so I'll just leave that small, since we don't want a lot of this being exported anyway. So we'll have it parse the track here, and we're gonna, let's take the chunk data and send it into the track. Parsed, we'll also get an error back from it. Why am I messing up on that? That's so stupid of me to mess up on that. All right. All right, and that'll help us out with parsing the tracks. Now the only issue is that parse is not a function yet. All right, I'm also, yeah, so parse is not yet a function. We'll go ahead and write that now. This can be data byte. And we'll return an error, return nil for right now. R equals bytes new reader, because we're going to be parsing through it on a very more granular level. We're going to, because each track is actually a stream of events. So let's first construct the reader. And the first thing we're going to read is going to be uvarint, an unsigned variable integer. This is something that MIDI has a lot of, and they use it all over the place. So let's read this first. And this is going to be our delta. And let's see here, binary uvarint. Fact is, there a wrapf function? Well, no, that won't give me a position data that I can actually use well. And this is giving me, it's because delta isn't being used yet. And we'll put that to use here shortly. So let me first do this. We're going to actually make sure that we can still parse the file. So I'll run the code again. And there's all of our track data. Quite a bit of track data. Well, 50 tracks lined up there. All right, so now we have a track. Now the challenge is to read events from the track. I'm going to create an event here. And each event has a delta time on it, which is going to be UN64. And all events will come off of this one. So then, let's see here. Okay, so now that we've read that, the next value we want to read from it is going to be... Actually, I messed up a little bit here. For r len is greater than 0. This way we loop through the track data. And actually, if I were to run it now, you would see an error. Oh, never mind. It actually parsed correctly. That's a little bit unconcerning. Let me just check something here really quick. All right. So then moving on to the next step here, we're going to start parsing the individual events from the track file. To do this, we first need to get the event type. And this is done by first selecting the a byte from it. And this is really hard to do. Because what we have to do now is we have to take the reader, read byte. We're going to need command and error. Whoops. Welcome to Go, where errors are all over the place. Where you can never get enough of errors. And now we're going to do a switch statement here. But we're going to do this a little bit weird. We're actually going to mask. So we only get the first part of it. Case. And I'm just going to set a default right now. And we're going to throw an error every time we encounter something that we don't know yet. So, error F, unknown event, X, command. If I were to run that now, we would actually hit an error. Yep. So you can see how the errors come out. Unknown event, FF. So let's parse that event first. FF is actually meta events. So we'll tackle meta events first in this. So case 0xF0. And we're going to have to do a switch in here because the Fs in the F0 set, you'll find out why I do it as mask here shortly, but for these system events, they all start with F. And there are sysx, which are F0, sysx escape, which are going to be F7, and then the meta events are FF. So we're going to do a switch on the command here. We're going to, once again, do default. We're going to throw an error if we hit something that isn't normal here. RF, unknown system event, %x, command. But what we're going to do is we're going to do a 0xff. And this is going to be our, this is going to be the event for meta events. Let me actually redefine something here really quick. We're gonna, let me see, where would that be? Yeah, let's do this here. So we're gonna define this as MIDI event. We're gonna actually create event interface and returns a delta time function, unit 64. Whoops. In fact, we could set this to a, would that be best to do that way? I'll just go with that for now. We can always correct it later. Why am I getting a undefined go? Define MIDI event. Oh. Misspelled MIDI. That'd be my own fault. All right. So we're going to create a variable here, event. I'll store an event. And we're going to go over here and add on events to this as an array. And let's also set up the events here. So then t events equals make event 0 because we're starting with absolutely nothing. And we'll just let go handle the array expansion. In fact, let's do this here. Error equals. Error does not equal nil. Return. Dot wrap. And then if everything's fine, we'll go ahead and we'll add the event in. So then events equals append to events. Event. And we're going to actually assign the event here. So event error equals a new meta event. We're going to give it the delta and the rest of the data for the event. Trying to remember if there's a format to the data. Let me just double check. Okay, so there isn't any set format to the data. So we're going to go ahead and, yeah, you're watching me figure this out in real time, basically. So we're just going to send in the reader. I'm going to create a new file as well, called meta events, or meta event. And this one I'm actually going to put multiple in. So then type meta event struct. I'm going to give it a subtype. And it's going to be a byte. let's see here. So we gave the delta you went 64. And we also gave a reader. It's reader. And we're going to be recording, we're going to be returning meta event. Just trying to think if there's anything I have to do with this in particular. Oh no, we'll actually be returning an event. I think about it. So it's going to fulfill the event type. In fact, I'm going to have this come off of MIDI event. And do we need subtype? No, I'll leave subtype in there. We'll fill that in as we go through. So anyway, for this first event, actually we'll skip subtype for now. We can do that later. It'll be annoying later, but we'll do it later. So we're given an event, and now we have to figure out what it is. There's a bunch of different meta events. So the first thing we're going to do is we're going to do that read of the first byte again. So the command or error, read byte. All right, now we're going to do a switch here. And I'm trying to remember how the meta events are set up. I think a lot of them do follow the same pattern. Yeah, it's subtype, then the length, and then the data. But not all of them have data. So that's where it gets a little bit awkward. So let's first read the length. And this is actually going to be read uvar from the reader. Another error to handle. So many errors. They're never going to end. And always handle errors. Don't assume that things are going to work out. That's just kind of a good strategy to use. And hold on a second. I just want to double check something here. One second. Did I actually get that close? Yeah, it did. All right, yeah, we're actually really close to some... Never mind, that's something different. So, now we have a length read. Now we're going to need data. And data is going to be a byte array of length. But I have to make sure that's going to be an int. But then here's the quirk. If I try to read into a zero length byte array, it causes issues. So we're going to only do it if length is greater than 0. And then we'll actually do the read. So then our read data. And let's... we don't need to know how much we've read. Yeah, another error. All right. So we're going to go ahead and put a switch in. We're actually going to return straight from the switch. So switch is going to be the command default is going to be turn nil errors dot rf error unknown meta event subtype. So next, by doing %x, it'll actually give it to us as a hexadecimal value rather than a decimal value. And frankly, all of the papers and such on the MIDI file format do it in hexadecimal, so it's just kind of making things easier. Command, and if I were to run this, oh, something's wrong over here. Oh. Am I returning nil here? What is the error it's giving me here? Undefined delta. Oh. There you go. So now if I run it, again, error, saying unknown event subtype 58. Which means we're getting further into the file. Yay! Okay, so now we're going to have to start into coding the individual events. So we first go and knock out what we've done so far. Alright, so we have track mostly done. I'll just leave that there. We're actually starting into the meta events, and I can kind of knock this one out. And we're going to go ahead and start into the meta events themselves. First one is 58, and we're going to tackle this one. We're going to tackle the ones that appear first in this file. So, first one's going to be the time signature. Just going to copy this over and throw it into here. So we have a note on it. Type and this actually has several values. It has a numerator, denominator, clocks, and again, to use to type English. 30 seconds. And these are all UN 8. And I shall also note that this also inherits meta event. So we're going to do case. Yeah, meta event, I don't have that set on it. So then case 0x58. Return new meta time signature. Call it that. We'll add in the delta. And we'll add in the data. So then func. This doesn't have to be exported either. New meta time signature. Can't even spell it. Delta is UN64. Data is a byte array. First thing we need to make sure that data is the correct length. So if the length of data is not 4, then something's wrong. And we also have to mark down that we're going to be returning an meta event time signature or an error. Well, both, technically. And our errors is going to be a new one saying, let's actually do invalid time signature length. Wanted 4, got, and the length here, data. But then assuming that everything went right, we can easily return this. And let's see, numerator is going to be binary big endian UN. Oh, what? I'm not even thinking straight. I just have to do this. Data 0, denominator, because all of these are actually bytes or uint8s. And I could actually call this a byte instead. I kind of use them interchangeably. That's just laziness. Don't practice laziness, kids. All right, 30 seconds. Data 3. What did I mess up on this line? Expect a nil. Oops. There we go. And then I need, got this in the wrong order. This should be a nil second. And now if I run this, all right, that has parsed correctly because now it's gone on to the next one, which would be a key signature. And we'll make the key signature the last one for now. I might stream a little bit later today, depending upon how I'm feeling. So let's go back to the main file and grab the key signature data. This one follows a lot of the same work. So up here, this is going to be case 0x59, turn new meta key signature, delta and data. I can actually do a lot of copy and paste with this. It's going to be key signature. I need to correct all this as well. For the key signature, we actually want 2. And this is going to be, but we're going to change things up a little bit. So first value is going to be the key signature's key. It's going to be our byte. I'm going to use byte here. I'll change this over to byte as well. Might as well try to keep it a little more consistent. And then the second is going to be for minor, which is going to be a Boolean value. And you'll see how we calculate that really quickly, even though I have it written right here. So then our key is going to be data 0, as that's the first value in the format. Then the second value is going to be minor. If it's 0 or major, if it's 1, it's minor. So minor data 1 is equal to 1. And let's try it out. Run the code. That works. Now we're on to 54, which I think is the SMPTE offset. Let me just double check. Yeah, SMPTE offset. And actually, we'll make this one the last one for now, and then we'll continue later on it. I actually just lost screen there for a moment, so give me a moment. All right, here we go. Let's copy this over to the MIDI events as well. I'm just going to remove it from here. That way everything stays nice and organized. We're going to duplicate this stuff as well. Don't you love multi-cursor editing? Well, I do, at least. That's going to be a length 5. Valid SMPT offset length. These are all byte. So hours, minutes, seconds, frames, subframes. I actually do it like that. It really doesn't matter what you do with it. We're going to go ahead and I actually just realized something I've been missing on these. Been missing the deltas. So let's do that event. MIDI event. Delta. Delta. And actually, let's change delta to capital. We'll go ahead and copy this over to the others. since that is actually something I was missing previously. Hours, data 0. Minutes, data 1. Seconds, data 2. Frames, data 3. And subframes, data 4. Let's double check that this is good. Yep. Go ahead and let this parse. Case 0x54. Return. New meta SMTP offset delta data. And now if I run it, we should get yet another error code. Kind of building it to get rid of errors. Next one will be 51. Yeah, I'll do one. I guess I'll do another one here. So let's do 51 really quick. I'm kind of getting addicted to it. So let's see, 51. Let me copy its definition here. Now the set tempo in MIDI defaults to 120 beats per minute. And typically this is only on the first track of the file. This doesn't usually appear on multiple tracks, which is going to make things complex. After we write the parser, we start going in to figure out the times, but we're going to do that later. I don't want to do that now. Although I probably should, but we're not going to do that now. All right, so let's go ahead and duplicate here. Yay for copy and paste. Whoever invented that is a genius. They probably copy and pasted their paycheck to get the extra money out of it, actually. All right, set tempo. And for this, we actually have just the MPQ, the microsecond. Well, actually, I'm going to call it UPQ. So then microseconds per quarter note. This M to me means milli, so I like to use U instead. And this is going to be data 0. We're going to want it to have 1. Set tempo length. We can call this UPQ. Actually, no, this is going to be 2. Is it 2? No, wait. I just realized this one is weird. Yeah. Forgot about this one. So this one actually is going to give us a uint 32, but it's encoded as a uint 24. So how do we do this? Simple. I'm going to do a little bit of a trick. I'm going to make a buffer here of 4 bytes. I'm going to copy over the data to the buffer starting at 1. And then we're going to do binary big endian uint 32 on that buffer. And that way I convert it into 4 byte. I convert a 3 byte value into 4 bytes, and I just find this works for this particular type of usage. All right, and then that should work there. So then let's see here. Case 0x51. Give me a moment. All right, now let's go and add this one in. New meta set tempo, delta data. We're going to check to make sure that this works. And that did work. So the next meta event type is going to be 2F, which I think is the end of track. That'll actually make for a good end to this particular broadcast. So let's do 2F. And this one actually has no data. Did I erase that one? Yeah. So let's do that. Go back into our MIDI event file. Type meta event end of track struct meta event. Now this one's a little bit different because we don't have any data coming in, so we can knock this out. I'm gonna have to rename this to end of track. We don't have to do any of this stuff, nor that. So that becomes really nice and simple. Very clean. Case 0x to F. Turn, new meta end of track, delta. And let's make sure this works. Yes, that works. The next one will be subtype 20, which I think is on the next track. And that's, I don't remember what it was for subtype 20. Channel prefix. But we'll ignore that for now. We'll get back to that later. This is just starting off the MIDI parser. So we'll continue in a later video. There's a lot more to code with the events.